Hello everyone. We're going to continue with the second part of the SMO Open 2020 problems and solutions. In the previous video we looked up to question 10, and up to question 10 a majority of it was what we called modified or just glorified A-level type problems, where if you are a student who is familiar with the A-level syllabus, you can make the most of that knowledge. But if you're a student who is not yet familiar with the A-level syllabus, there will be some ways that you can use basic understanding plus your Olympiad knowledge to compensate for that. Now we'll be looking at the next section, not all the remaining 15 questions, but we'll be looking at the next section where these problems are, at least for the most part, going to not quite be A-level type problems. They are mostly going to be full-fledged Olympiad questions. It's important to note also, as we look at some of these problems, that there is a huge difference between the SMO round 1 and the round 2. So for many of these ones, you can find patterns and you can guess, because it may not be possible within the time frame to find an easy or efficient solution. So let's look at question 11 to start off. A is the set of numbers from 1 to 10. We are asked to count the number of pairs of non-intersecting non-empty subsets, such that the largest number in S is smaller than the smallest number in S2. So which means that essentially S1 and S2 are a bunch of numbers, and if you were to kind of draw it on a number line, it means that we are saying that S1 would be this and S2 would be this. Whenever we are asked to count a pair, or rather count how many ways there are to form a pair, our tendency is to go and try to form the first one and then the second one. That is sometimes a very good idea, but in this case, not such a good idea. Because if, let's say, I've already decided on S1, then the number of ways to select S2 is not necessarily going to be something that is so easy to express. And so I will suggest a couple of ways that you can handle something like this. The first way is to decide on the largest number in S1. So split by the largest element of S1. If if the maximum of S1 is 1, that means that there's only one choice for S1, which is that it only contains one element. And for S2, it can use any of the things from 2 to 10, except that it is non-empty. As we are mostly familiar with, when we want to count the number of subsets, it's just going to be for each element, you either pick it or don't pick it. So you have 2 to the power of 9 minus 1 choices. Minus 1 because of the non-empty. If your largest element is 2, then there will be 2 choices for S1, which is depending on whether or not you pick the element 1, and 2 to the 8 minus 1 choices for S2, because now there are 8 things to choose from. This will continue, sorry, not 3, 2 squared. If the maximum is 3, now there are 1 and 2. And this goes on until the maximum of S1 is equal to 9, in which case you have got 2 to the 8 times just 2 to the 1 minus 1, which is, of course, 1. A very quick computation of this is possible because you are just going to get 2 to the 9 appearing 9 times, and then the sum from 1 to 2 to the power of 8. Oops, I realized that's not within the screen. Let me write that below. 2 to the 9 times 9. Sum from 1 to 2 to the power of 8. This is 2 to the power of 9 minus 1. And so therefore, when you subtract off, you end up with 2 to the 9 times 8 plus 1. This is 2 to the 12 plus 1, which, if you are familiar with your powers of 2, is 4096 plus 1. This is one option. The second option, which is neither better nor worse, it's just a different option, is that you can decide to pick their union first. And once you pick their union, S1 is going to involve some of the small numbers in a very fixed way, which is the S1 is either the smallest number, or the two smallest numbers, or the three smallest numbers, and so on. So you split by the size of the union, which must be at least of size 2 and up to size 10. Now I can lump this all into a single summation. Firstly, if I have picked that I want a size of n, there are 10 choose n ways to get that set. There are 10 choose n ways to get that set, and it would further split up that for each of those sets, you can give anything from 1 to n minus 1 elements over to S1. So that would be n minus 1. Now this is already going to be the expression. In some sense, for symmetry's sake, I can add in 1, because that choose 1 times 1 minus 1 is just 0. And in fact, I can further make it symmetric by adding 0 in. 10 choose 0 times negative 1 is minus 1. So I'm going to write it like this. I want to write it like this because the sum of 10 choose n, as n goes from 0 to 10, is just going to be 2 to the power of 10. That's because this is basically just the binomial expansion of 1 plus 1 to the power of 10. Sorry, I realized that now I've ran off the screen on the left side. So let me do a little bit of an adjustment. So now you should be able to see the summation. Yeah, so as I was saying, I was adjusting it to be from 0 to 10, and from 0 to 10 of 10 choose n is 2 to the power of 10. For n times 10 choose n, as n goes from 0 to 10, this is interesting because you could calculate it directly, but you could also have a combinatorial argument to say that this is the number of ways to pick any number of people, and then from that number of people pick one special person. So pick one special person and any number of others from 10. This is going to give you 10 ways to pick the special person and 2 to the power of 9 for everything else. Now this is pretty neat because when you realize this is what those things are equal to, it will reduce to exactly the same quantity as what we had before. So this is going to be 10 times 2 to the 9 minus 2 times 2 to the 9. So same result in a slightly different way. Okay, I'm going to be a bit mindful of not going off the boundary of my screen sharing here. So Let's try to write a little bit more in the center for the next problem. Question 12. Each cell of a 2020 by 2020 table is filled with a number which is either 1 or minus 1. Your Ri's and Ci's are the products of the numbers in the ith row and ith column respectively, which obviously are themselves also 1 or minus 1. Now suppose Ri plus Ci equals to 0 for all I equals to 1 to 2020. What is the least number of minus 1s in the table? Ri plus Ci equals to 0 just means that there is a 1 and a minus 1 in some order. Least number of minus 1s in the table just means that, well, most of them should be 1. Now I'm going to think of it as being a small, like let's use a 4 by 4 as a representative size to understand what's going on. This is of course the SMO Open 2020, and we are not really sure how important the number 2020 is. However, very often if the number is significant, you would like to make the same parity. So if 2020 is even, I would like to use an even size, because oftentimes that is important. That may not be the only reason why 2020 is important, or it may be, we will see. But I use the same parity for an example, just so that I don't have the risk of odd and even looking very different. For 2020 by 2020, it's too big to work with, but for a 4 by 4, I can think of it as the products are all starting at 1. Assuming that I have, by default, the whole table, when I don't write anything, is made up of 1s. I would like to put in some minus 1s. And every time when I put in a minus 1, let's say if I put 1 here, it is going to switch 2 of these rows from 1 to minus 1. I don't really want to switch that row and that column to both minus 1s. Because I would like it to be 1, 1 and 1 minus 1. So it would be better to do this instead, because in that way, first row and first column, as well as the second row and second column, both have what they want. And I can just repeat this again down here. As we can see, now the third row and third column, as well as the fourth row and fourth column, both have what they want. Now this generalizes quite easily to the full table. We just continue going down this diagonal, and each time when we put in a minus 1, we have switched 1 row and 1 column, which we definitely need to at least do this 20 times. So you need at least 20 minus 1s in the products. So at least 10 minus 1s in the table, which we have seen can be done just by filling alternate squares on this next to the long diagonal. So the answer would be 10. For the next one, question 13, as well as I believe 2 questions later at question 15, we have a couple of questions on, well, sequences, specifically arithmetic progressions. In my opinion, arithmetic and geometric progression questions, which are also an example of an A-level topic, usually they can't be much more than just an algebra exercise, because the meaning of arithmetic progression and geometric progression is that you have a bunch of numbers which are determined by a couple of variables, the first term and the common difference or ratio. In this case, arithmetic progression means first term and common difference is what we care about. And so I can just let my terms, first term be A and common difference be D. The equation that I'm given will be just a linear equation in A and D, which gives me A plus 4D equals to 8. So this is a given. In fact, it's the only given constraint. It doesn't even tell me that the terms are positive or that the terms are integers, so I know nothing else other than this. Find the maximum value of S8 times S10. Now, S8 means add up until A plus 7D, and S10 means go up to A plus 9D. There is a formula for the arithmetic series, but I don't think we need to remember it. It suffices just to know that S8 will be 8 times of the average. And the average can be obtained by using the average of the first and last term. So this is S8. And this would be S10. At this juncture, we realize that this is nothing more than a straightforward single variable algebra exercise. Just multiply S8 with S10. And we can substitute A equals to 8 minus 4D to make it that single variable that we would find easiest to optimize. So you realize that, humorously enough, this just simplifies to the difference of squares, whereupon the maximum value, which is what we want, just happens when D is 0. There's nothing wrong with D being 0 because the question didn't say a non-constant arithmetic progression. So as much as that feels a bit anticlimactic, we can say that the maximum is when D equals to 0. Our answer is 5,120. Question 40. Consider all functions g from reals to reals satisfying two conditions. Firstly, the absolute difference between GA and GB is less than or equals to the absolute difference between A and B for any real numbers AB. And secondly, g of g of 0 is 0. Find the largest possible value of g of 0. The answer to this is 0, perhaps not very surprisingly. Some problems like these are very guessable, but actually not very easy to solve in full. So in a competition environment, you should certainly look at it, and if you're stuck, please guess. In a practice environment, it is quite an instructive question for us to learn how to manipulate conditions on functions such as these. By the way, there is actually a term for this sort of condition, that the difference between G and GB is less than or equal to A minus B. This is actually a Lipschitz constraint. A Lipschitz constraint, or a Lipschitz constraint, is that the function is not changing too quickly. Of course, the Lipschitz constraint can be with any constant on the outside. It's basically telling you that in some sense, the derivative is going to always be between -1 and 1 when the derivative is defined. Okay, so that's not important for the question, but just worth mentioning. When I'm looking at this here, I need to put some stuff into this condition here, and all the things in the question have to do with 0. And so I'm going to look at the numbers, well, 0, g of 0, g of 0, and then g of 0 is just going to be back to 0 again. Now, when I draw this triangle here, do you realize that we are immediately done? We're immediately done because basically it tells you that once you have applied the function, the gap is getting smaller. So that means that these two are going to be closer than these two. But then also that these two are closer than those two and these two are closer than those two, it loops around and you just end up with all of them are actually going to have the same gap. I'm not going to write so many of these g's everywhere, but just to highlight that it's just more and more g's can be topped up because g0 is 0. So I'm not actually doing anything wrong here by writing it like this. So all these three things are going to be equal to each other. These two are the same thing. So g0 minus 0 is g0 minus g0, which is equal to g0 minus g0. So that's 0 minus g0 is g of 0. And it should be abundantly clear that if there are two numbers whose difference is equal to their magnitudes, the only way that this can happen is that they're all 0. Another way of thinking about it is that if you go from here to here to here and all of them have the same difference, the only way that you can take 3 steps and end up where you started with is that your steps are of size 0. You haven't gone anywhere. It's a bit anticlimactic because the whole question is full of zeros, but I kind of like this question as being just a flavor of a round 2 problem, except that it is quite guessable in the SMO round 1. Question 15. We are back to arithmetic progressions again, with an additional good sequence constraint. I don't really know what to say about this good sequence, except that it feels very unlikely to be a coincidence. And so if I were to just do the same definition as before, Sn and S2n will be n times of the average, and let's just see what it looks like. So this one Vn times 2a plus 2n minus 1d. As I'm looking at this, remember that this is supposed to be the same regardless of n. So if I were to divide S2n over Sn, it's supposed to not change. Now, it's supposed to not change, but that seems to be quite unlikely, because if, let's say that just put in n equals to 1, and we can ignore the 2, actually I'm a bit blind, right? I just realized that I forgot a1 is 1. That's great. Let's change all the a's to 1s then. That makes my life even easier. Yeah, that makes my life even easier, because it should be pretty clear now, but for completeness sake, if I were to put in this here, it should be even more obvious that if you had something like this, we can find d just by putting in a couple of values of n, like 1 and 2. Is enough for us to check that. Okay, so if I move this over, I get d squared minus 2d is 0. And this time, of course, the question tells me that does it say non-constant? It says that a2 is not 1. Okay, so it's not a constant sequence. So d is not 0. D is 2. Just to be sure, if d is 2, yep, that's just 4. So it is really constant. Great, so d is 2, and my question is A2020. A2020 equals to 1 plus 2 times 2019. Obviously, I goofed up a bit by not reading the question saying that there is a 1 down here. That's mainly because it felt like I didn't even need that in order to say quite a lot about this statement, but all the better if it tells me that A1 is 1. So A2020 will be 4039. Question 16. Determine the smallest positive integer p such that this system has more than one set of real solutions in x, y, z. If we take a look at this, at one glance, I don't really see why this shouldn't have more than one set of real solutions, because there are two equations for three unknowns after you have selected p. But clearly there is some reason why this is a question, and I could just test it out by letting p equals to 1. But that feels like it's not going to accomplish anything. If the answer is no, that will come after a lot of work, and the answer is that, oh, that just fails, then, well, we'll figure that out soon anyway. Now, another thing that I'm noticing is just that, well, there will at least be one solution. X, Y, Z can always be 0. So having a solution is not news. Having more than one solution is news. Alright, so with, for want of a better idea, I'm just going to take the first one and substitute it into the second one. I can write x in terms of y and z, y in terms of x and z, or z in terms of x and y. All of those are fine. I'm just going to write y in terms of x and z since 4y and 2y are here, and I don't want to just make the p appear more times than it should in an equation. Okay, so this is going to go into here. Y is half of 4y. Now this is already just a quadratic in x and z. So that's good, I think. So minus 6x squared minus 3 half z squared. I've got minus 3zx minus 3zx plus p. So plus p minus 6xz equals to 0. If I clear all the minuses and arrange it in order, this needs to have a solution for x and z. Now this is a quadratic, but I want to be careful in how I say this. This is not really a quadratic equation like just, oh, there's just x and z here. If I divide by z squared, I can say that this is a quadratic in x over z. And so this would allow me to safely use my discriminant. The question here is, and we need to be careful with this, do I want this to be positive, negative, 0, or what exactly can I accept? In the 2020 SMO Open, many students basically auto-completed in their mind, or has more than one solution. More than one solution means greater than. That is normally true, except that you don't realize that if you have one value of x over z, that already gives you infinitely many values of x and z. If I told you that x over z is 5, that means that x and z, x just is anything that's 5 times of z, that's infinitely many solutions. So I only need one solution. And so the more than one set kind of tricked a lot of students, and not to mention that 0, 0, 0 also works, so that's also going to be one trivial solution there already. It can be equal to 0 therefore, and this is not a very hard equation to solve when you equate it to 0. You just end up with x minus p is greater than or equals to 6, or less than or equals to minus 6. So p less than or equals to 0, or p greater than or equals to 12. The problem asks me for smallest positive integer, and so therefore 12 will be the smallest positive integer. For question 17. For question 17, this was a question that was sort of repeated in the 2021 SMO Open, which I've just last reviewed a few years ago, so I don't remember what I said in that video, but it certainly was a repeat of this question. The SMO does that once in a while. They do repeat questions. I personally do not think that's a very good thing, but it does happen. So as you're watching all these videos, do not memorize the answers blindly, but do understand the approaches, because once in a while they do actually have an almost identical question with just a little bit of different names. the first thing that I want to do is to literally split this question in half. Sometimes I realize that the question is very much a two-parter. Don't try to do both parts at the same time. The first part is telling you something about a triangle. The second part is to do with the circle and picking a point on it once the triangle is already known. So I can deal with the triangle first and try to discover as much as I can about it. This looks weird. It looks weird because I can see that B over A is actually sine B over sine A. And so therefore, this looks very much like as if I swap them over. Okay, let's write it out. Cos A sine A equals to cos B sine B. This is A and A on one side, B and B on one side. So I can use my double angle. Cancel the half. When two sines are equal, and these are angles in a triangle, it means that either they are equal or they are supplementary. They can't both be negative. That's clearly not going to happen. And so this is also not going to happen, because if A equals to B, then 4 over 3 would not happen. So the conclusion is that A plus B is 90 degrees, and so C is 90 degrees, and in fact this is just a 3, 4, 5 triangle, with C being 100. All the same, it is just a 3, 4, 5 triangle. It's not 3, 4, 5, the ratio is 3, 4, 5, but 60, 80, 100, since that's the length of C. Okay, so this is my triangle, a very specific triangle. It's a very specific triangle, and now I want the maximum value of PA squared plus PB squared plus PC squared, given that it's on the in circle. Well, let's put the in circle down. Now for the in circle here, I need to know first how big is this in radius. Remember, P is not the center, P is a point on it, but I do still want to know where is this center and how big is the radius. There are various ways to do this task, but I think the easiest one would just be to call that R. 60 minus R, 60 minus R, 80 minus R, 80 minus R, and then 100 is equal to the sum of these two. So R is 20, which means that, well, what does that mean? Well, it doesn't really mean anything, does it? It just tells me where the circle is. So I now know what the triangle is and where the circle is, but I'm still not very sure what is the PA squared plus PB squared plus PC squared really going to do. And so the easiest way to make use of that information, in my opinion, is just to set this up in terms of coordinate geometry. I'll erase this off and now label them in terms of coordinates. Right, radius is 20, so 20, 20, and the equation, of course, I could write the equation as, well, x minus 20 squared plus y minus 20 squared is 20 squared. That is indeed the equation, but I would just parameterize it in this form. So P is 20 plus 20 cos theta, 20 plus 20 sin theta, where theta is just whatever that angle is. Now once I do this, then I'm just going to get slightly annoying, but frankly not very difficult computation for what my PA squared plus PB squared plus PC squared would be equal to. So 20 cos theta minus 60 squared. Now they're all squares, and so therefore I don't even have any square roots appearing. So PB squared and PC squared, which means one more of these two again. You can factor out 20 squared from everything. There are now going to be quite a lot of simple cancellations algebraically, which leaves us with 3 cosine squared theta plus 3 sine squared theta, those will cancel, plus 4 minus 6, so minus 2 cosine theta, plus 4 sine theta minus 4 sine theta, that's gone, and then plus 9 plus 2 plus 2 plus 4. This is 3 plus 17, so 20 minus 2 cosine theta. And you want this to be maximized. Now, for this to be maximized, it means that I would want cosine theta to be negative 1. Which means actually it was meant to be this point. Perhaps there's some good way to explain why that's the best point, but I think it's not extremely obvious at the start that you must pick that point. If you don't know better, you could always just guess that it should be one of these three, and it turns out to be this one. You could check all of them, but I think I would just prefer to do this because it is not so clear. The answer is 8800. Finally, let's do question 18 to end off this video. We want to find the largest positive integer n less than 2020 such that this thing here is divisible by n for k equals to 0 to n minus 1. I am not sure what to make of this, to be honest. When I'm reading this, I'm just thinking, well, let's see. Right? If k equals to 0, this is n minus 1 minus 1. Is that right? So no, this is not. This is 1. N minus 1 through 0 is 1. So this is 0. There's nothing to say there. For this one, it is n minus 1 choose 1. This is n minus 1 plus 1, that's n. So still nothing to say there. K equals to 2 then. N minus 1 choose 2. Minus 1. This is n squared minus 3n plus 2 over 2 minus 1. Now this is divisible by n if this is an integer. So it means that n must be odd. Let's do one more to just continue to get some sense of what's happening. I don't really want to expand out anything beyond n minus 1 choose 3 anyway. But 3 factorial is 6 plus 1. So I realized that actually at the end this coefficient there is getting cancelled off, which is an interesting thing to me at least. N cubed minus 6n squared. This is plus 2 plus 3 plus 6n minus 6 over 6 plus that, so this is what I have here. Now I need this to be a multiple of 6. N squared minus 6n, if n is odd, this is already divisible by 2. For this to be divisible by 3, mod 3 on top, n squared minus 1 is congruent to 0 mod 3, so n is plus or minus 1 mod 3, so not a multiple of 3. Okay, so n is odd, n is not a multiple of 3. I'm starting to think that n should not have factors. Maybe n is prime. I know I'm going less than 2020, right? So 2019 is divisible by 3. That's excluded. 2018 is even, so that's excluded. And 2017 is prime. So maybe 2017 works, right? I don't even need to know that it works for all primes. I just need it to work for 2017. But you know what? Let's just try to write it in terms of p, because there's nothing interesting about 2017 other than the fact that it is prime. So let's test that out. Let n equals to 2017. And now I am looking at n minus 1 choose k, n is 2017. I am just going to write down all this stuff here. So 2016 factorial over k factorial 2016 minus k factorial. The interesting thing that I'm realizing is that 2016 factorial, Wilson's theorem tells me this immediately. Meanwhile, if I have k factorial times 2016 minus k factorial, just writing down what the numbers are, I'm realizing that this is, well, if I were to write it just in the usual way, right, and then cancel off the 2016 minus k factorial, I could also just write this in terms of mod 2017. These are all just negatives of the denominator. So I don't even need Wilson's theorem, right? So for Wilson's theorem, it gives me the sense that this is probably a good idea, but I never really needed that because all of these are just going to cancel off and leave me with what? Well, not what. The same 1 of minus 1 to the k. So that cancels off and gives me 0 mod 2017. Take note that this is not a proof that only primes work or that all primes work, but you will see that it's quite easy to tweak this to say all primes work, and I'll let you think about whether there are cases for non-primes where this thing would actually be true as well. But otherwise, that means that it confirms, for this question at least, the answer is 2017. This is also where we will wrap up this second section of our Open 2020 review. I'll see you again for the last section where we'll go through questions 19 to 25 in the next video.